Okay, so now moving on to activity number 1.4. So here the first question is, consider the following functions where R is a set of real numbers and N is a set of natural numbers, Z is a set of integers, R plus is a set of positive real numbers, R minus is a set of negative real numbers. So they have given 5 functions, the domain and codomain, right? So the first function is mapping R to R. This is mapping N to R, R minus to R, R plus to R, N to Z. So what is the question? Which of the following represents a sequence? So if we remember correctly, the sequence, the first number, let's say if we have an, so here n only takes natural numbers, right? So here the first, that is the domain of the function must be a natural number, right? In the given options, only f2 as well as f5 takes natural number as a domain, and it maps to R or Z. We are not bothered about the codomain. So the correct options are option 2 as well as option 5. Next question we have, let an be a sequence defined as an is equal to some function. The limit of the sequence an is, so they're asking us the limit. So whenever they're asking a limit of a sequence, it means that it is limit n tends to infinity of that particular sequence or function, right? So here limit n tends to infinity, the given sequence is 3n square plus 5n plus 2 whole divided by 4n square plus 2n plus 1. So right, so if we directly substitute the value for n, that is infinity, so what we'll have, infinity by infinity. So this is a indeterminate form. So to avoid that, I will use L'Hospital's rule. Okay, LH rule. So if we are getting an infinity by infinity form, it says that we can independently differentiate numerator and denominator with respect to the given variable. So since this is a variable of one single function, variable function, we can easily differentiate this. So the differentiation of the numerator is 3 times 2 is 6n plus 5. So the constant will be cancelled out. So we have the denominator, we have 4 times 2 is 8n plus 2. Again, if we substitute n as infinity, again we will be having infinity by infinity form. So again I'll apply L'Hospital's rule. So this will be giving me limit n tends to infinity. Again, if I differentiate, I'll have 6 by 8. So now there's no point in applying limit as there is no n. So I'll have 3 by 4 as the answer. So this is the correct option. Okay, moving on to the next question. Okay, consider the sequence n square. Which of the following options are subsequences of the given sequence? Okay, so let us say I have a sequence of n. So let's say, what is this n? Let us say, so this is nothing but n belongs to natural numbers, so that is nothing but n is equal to 0, 1, 2, 3, 4, etc. Let's say what will be the subsets of n. Let us check now. So what will be n plus 5? So n plus 5 is nothing but, so I'll have 5, n plus 5, 1 plus 5 is 6, 2 plus 5 7, 3 plus 5 8, and so on, right? Again, this is a subset of n. First option is correct. So what about 2n plus 1? So I have 2n plus 1, right? So if I go on substituting, I'll have 1 comma 2 times 2 is 4, 4 plus 1 is 5, plus 2 sorry, so I have 3 5. What about if I substitute 3? I'll have 2 times 3 is 6 plus 1 7. so I'll have odd numbers. Again, this is also a subset of n, so this option is also correct. So the third option I have 2n plus 1. I know that 2n plus 1 is a subset of n, but what about this power? This power is not matching with the given sequence, so this is the wrong option. What about the fourth option? Again, the index is not matching. This is not the correct answer. Any set is a subset of itself, right? So similarly, any sequence is a subsequence of itself, so this option is also correct. So what about 2n square? Right, what about 2n? Since the index is same, I'll just consider I'll consider n square. N square is nothing but 0, 1, 4, 9, 14, etc. What about 2n square? 2n square is nothing but 0 as well as 2, 8, I'm sorry, in the question, so it is we have 2n whole square. So since the indexes are same, I'll consider 2n again. So what will be 2n? 0, 2, 4, 6, etc. Set of even numbers, right? So again, this option is also correct because this is a subset of n. So option 7 I have 1 by 2n plus 1. So if I substitute n is equal to 0, 1, 2, 3, what will be the sequence I'll get? If I substitute 0, I'll have 1, comma. If I substitute 1, I'll have 3 by 2. This is not in n. This does not belong to n. So this option is wrong. So what about an plus 1 the whole square, where a belongs to z and not equal to minus 1. So let's say an plus 1. So this is similar to this one, right? Okay, so what happens if I put any other number? Let's say if I substitute 3. Okay, a is equal to 3. I'll have 3n plus 1. So what will be the sequence? 1 and 4, 7, etc. So if I substitute any value for a, and I'll get the same subset for the n. Again, this option is also correct. Moving on to the next question. Let an be a sequence converging to the limit 1. Then which of the following options about the mentioned subsequences is or are true? Okay, so they have given us limit n tends to infinity of a of n is equal to 1. This is what they have given. So they are asking us limit n tends to infinity a of 2n, right? So if we as we have seen in the previous case, if n is replaced with any subset of n, okay, the limit does not change. Okay, so here 3n is again a subset of n, so first option is right. So what about 2n? Again, 2n is a subset of n, but the limit is different, so this is not correct. What about 3n plus 1? 3n plus 1 is a subset of an, is a subset of n, but this limit, the value of limit is wrong. So what about the last option? 6n is a subset of n and it is converging to the same limit, so this option is correct. Next question. So we have a sequence an defined as root of 2n plus 1 minus root of 2n. Which of the following options is correct? Okay, so they are talking about an is convergent, or the limit of an is 0, limit of an is they're asking us to indirectly find the limit of an. Okay, so how to find this? So limit n tends to infinity of an is equal to limit n tends to infinity of square root of 2n plus 1 minus square root of 2n. So what will happen if I substitute infinity directly, right? So if I substitute infinity directly, I'll have infinity minus infinity, which is again indeterminate form. So to simplify this, I'll have to rationalize this. Okay, limit n tends to infinity, and if I rationalize, I'll multiply and divide by root of 2n plus 1 plus root of 2n. So I'll have this, the numerator will be in the form a square minus b square. So I'll have 2n plus 1 minus of 2n whole divided by square root of 2n plus 1 minus square root of 2n whole square. Okay, so I'll have limit n tends to infinity, 2n will be cancelled. I'll have 1 divided by 2n plus 1 plus 2n minus 2 into square root of 2n plus 1 into 2n. Okay, so now if I substitute n as infinity, okay, so I'll have 1 divided by infinity, right? So this will be nothing but 1 divided by 1 by 0. This is nothing but 0. Okay, so the option 2 is correct. So since the limit is not going towards infinity, right, so it is coming back to 0, right? So this will be convergent. So the next question, I have a sequence defined by an is equal to n to the power of 1 by n has a limit, and given that we have limit n tends to infinity, n to the power of 1 by n is equal to 1. So which of the following is or are true? Okay, so the first option they are asking us to find out limit n tends to infinity ln of n to the power 1 by n. Okay, so we know that limit of n to the power of 1 by n is given by ln of n to the power of 1 by n is nothing but 1. So ln 1 is 0. The first option is correct. The second option we have limit n tends to infinity ln of 1 plus n to the power of 1 by n. Again I have ln 2, but ln 2 is not equal to 0. Second option is wrong. So I'll have option 3, I have limit n tends to infinity ln of 1 plus n to the power of 1 by n, limit n tends to infinity ln 2 minus 1 by n whole divided by ln of 1 plus n to the power of 1 by n. So if I substitute the value of n to the power of 1 by n, I'll have limit n tends to infinity ln 2 minus 1 by n whole divided by ln of n to the power of 1 plus 1 by n is 1, 1 plus 1 is 2. So this can be written as limit n tends to infinity 1 minus 1 by n into 1 by ln 2. Okay, so I can substitute n as infinity. I'll have 1 minus 1 by infinity is nothing but 0. So the answer is 1. So the third option is correct. So what about fourth option? Fourth option I have limit n tends to infinity of 4 n to the power of 1 by n 3 by n minus 1. So this is limit n tends to infinity of 4 of n to the power of 1 by n whole cube minus 1. Right, n to the power of 1 by n is 1, 1 cube is 1, 4 minus 1 is 3. So I have also have lan here. So limit, I'm sorry, there is no lan here. I have made a typing mistake, sorry. So there is no lan. So what happens here, if I substitute limit for this one, I have 4 into 1 cube minus 1, so that is nothing but 4 minus 1 is 3. Again option 4 is also correct. So moving on to the next question. Let an and bn be two sequences such that the magnitude of an is always less than or equal to magnitude of bn for all n greater than or equal to m, where m belongs to the natural numbers and limit n tends to infinity, bn is equal to 0. Then find the limit of an. So we have to find limit n tends to infinity of sequence an. So this is what have they given. They have given limit n tends to infinity of sequence bn is 0. So it means that, let us say, if I have a graph, let's say, I'll change some colors. Okay, so they are saying that this sequence is converging to 0. Let's say this is the sequence. Okay, so this at infinity, this will be converged to the x-axis, right? So let's say this is sequence bn, and they have said that an is always less than or equal to bn. It means that an will be always below bn. So by intuition we can say that also an also converges to the x-axis. That is, the limit of an will be also equal to 0, right? Since it is always less than or equal to bn, if bn tends to 0, an also tends to 0, because we have less than or equal to condition, right? So moving on to the next question. So we have we have to find out whether the given functions are increasing or decreasing functions. So let us start with option 1. Option 1 is 3n minus 5 divided by 4n plus 2. So to find this out, we can easily substitute n as 1, 2, 3, 4, etc. Right? So if we substitute n as 1, the sequence that we will get is 3 minus 5 is minus 2 divided by 4 plus 1 is 4 plus 2 is 6. If we substitute 2, we have 6 minus 5 is 1. Divided by 4 into 2 is 8 plus 2 is 10. So if we substitute 3, we have 3 times 3 is 9. 9 minus 5 is 4. 4 divided by 4 into 3 is 12. 12 plus 2 is 14. And let's substitute 4. 4 into 3 is 12. 12 minus 5 is 7. Divided by 4 times 4 is 16. 16 plus 2 is 18. So as you can see, the sequence goes on increasing, right? So this is not a decreasing function. The option 1 is wrong. What about option 2? Option 2, we have minus 1 divided by 6n minus 5. So if we substitute 1, 2, 3, let's say minus 1 divided by 6 minus 5 is 1, comma minus 1 divided by 12 minus 5 is 7, minus 1, comma we have 6 minus 6 into 3 is 18. 18 minus 5 is 13. So how does this graph looks like? So this graph looks like something like this, right? So this is an increasing function. So option 2 is correct. So what about third one? Third one we have, square root of n plus 1 minus square root of n. So if I substitute 1, I'll have root 2 minus 1 comma, I'll have root 3 minus root 2 comma, I have root 4 minus root 3, right? So this is neither increasing nor decreasing, right? So this is also wrong. So what about fourth one? So fourth one, we have square root of 2n. So in square root of 2n, again we have square root of 2 comma square root of 4 comma square root of 6 comma, and so on. So again this is an increasing function. So option 4 is correct.